Hey, Chem 11, this is a quick lesson today looking at some of the answers or really some of the questions from the Molar conversions worksheet. A whole bunch of you have handed it in. Thanks for doing that. I've also received some of you asking for a little bit of support with it. I thought what it would be useful would be to review some of the later questions in the sheet. Reason for that is there's one where there was a typo in the sheet, sorry about that, but I'll get into it. And the other is where there was there are multi-step questions, and I think those would be useful to review as well. So I'm going to start with question 17 on the Molar conversion sheet, and I'm going to go from there. So in question 17, you're being asked, in the original question you were asked, the density of a gas at STP is 0.75 grams per liter. What is the mass of the gas? Well, that doesn't make sense because you're not being given a volume here. What you're actually being asked for here is what is a molar mass. Now, you saw that there was an equation I gave you for density, where you take the molar mass and divide it by the liters per mole. Here, you need to rearrange the equation. You need to rearrange the equation, and here's the different equation you get. You get molar mass, that's the m mole part there, equals the density times your 22.4 liters per mole. I'll zero in on that, and I'm going to try and get a better pen. There. That's the equation I'm talking about. So we'll work with that for this question. Now, first thing here, we need to, this is just a matter of plugging information through. The thing I like to do first, and I really recommend you do first, is to write out your equation. You're going to see in the answer key that I've done that. I've written out everything in a very step-by-step way, including the units. So let's say the density. I know it gives that in the question. I'm going to put it in again. The density is 0.75 grams per liter. We then unify what I've given you. We take the equation, we put that figure in there, and we get our answer. Molar mass is 0.75 grams per liter times 22.4 liters per mole. So when you do that calculation, the answer that I found that you're going to see in the answer key is 17 grams per mole. I'd like you to notice something there, that I rounded that figure. The original information you were given gave you two significant digits, 2.5, 2.5. You have two sig figs there. You're not allowed to have any more than two sig figs in your answer. That's an important point that you need to take into account when you're answering these kinds of questions in chemistry, these kinds of questions in physics. $17 grams per mole. All right, I'm going to try to do the next ones a little faster. Question 18. How many oxygen molecules are in 3.36 liters of oxygen in STP? Here's where you're using that mole bridge I talked about. You can go back and forth between particles, moles, mass, and volume. The moles are in the middle. They're the bridge for all the other units. So if I give you particles, you can tell me moles. But what's kind of cool is if I give you particles, you can then go from moles to mass. If we know what the substance is we're talking about, we can figure out its molar mass, and we can get its mass. We can do calculations relevant to particles, moles, and mass if we're given the required information and then told, hey, what else do we need to know? The mole bridge, that means that you have moles in the middle, and you can use that to do multi-step calculations to get further answers that are in like more complicated questions. Looking at question 18, we were asked how many oxygen molecules are in 3.36 liters of oxygen gas. Molar mass here doesn't matter. What does matter is this. We have this equation. N equals V divided by 22.4 liters per mole. P for particles equals N for moles times this thing right here, big N-A, Avogadro's number. We now say what we know. V equals 3.36 liters of oxygen. N equals your 3.36 liter figure of oxygen divided by 22.4 liters per mole. I get 0.15 moles of oxygen. Notice I'm keeping in everything here. I'm keeping in those figures not only of the units, but what are the units of? The units are of oxygen. Not just any volume or chemical amount, a chemical amount and volume of oxygen. Now we want to go to particles. Well, we need to use that molar amount next. There it is, 0.15 moles of oxygen times 6.022 times 10 to the power of 23 molecules per mole. Remember that a mole is Avogadro's number of everything. The number that we're talking about here, that we're quantifying, that we're counting, is oxygen molecules. Sometimes I'm working with atoms, in which case I'm going to put atoms right here. Sometimes I might be working with ions in electrochemistry, Chem 12, in which case you might have ions right there. So what type of thing you put right there is going to depend on the original question. New line. When I did this, I got 9.0 times 10 to the power of 22 molecules of O2. There. That's question 18. Question 19, we're asked, find the mass in grams of 2.00 times 10 to the power of 23 molecules of F2. In my answer key, you'll see I've got two equations I'm using. The one for calculating molar amount, chemical amount, from number of particles, and the number for the equation for calculating mass when you're giving chemical amount and molar mass. Another multi-step question. Our equations. N, chemical amount, is P, particles, divided by Avogadro's number. M, mass of the substance, equals your chemical amount times your molar mass. Always. These are equations that work for any situation in chemistry. So, working with those, let's put in what we know. We put in our equations, then we put in what we know. So, here's where we're at so far. Number of moles is that number of particles of fluorine gas, molecules of fluorine gas, divided by Avogadro's number. I get 0.332 moles of fluorine gas. Now we need the molar mass of fluorine gas. What is it? When I did this work, sometimes I was going into the textbook and the periodic table there, but I like to be exact, and so when I wasn't getting a lot of sig figs from that, I was going online to the dynamic periodic table, finding those figures right there, those molar masses. Here's what I found. I get 38.0 grams per mole. At this point, I'm hoping you're comfortable with doing this. We see that to find that, each molecule of fluorine gas has got 2 fluorine atoms joined together. Each fluorine atom, well, the grams per mole of fluorine itself as an element is 19 grams per mole. But when you have a molecule made of 2 of them, a mole of that molecule is 38.0 grams per mole. It has a mass of 38.0 grams. So this is where that 38.0 figure comes from. Now let's put it all together. The mass is 0.332 moles of F2 times 38.0 grams per mole, and I get 12.6 grams of fluorine right there. That's the answer I get for question 19. Question 20 is the last one I want to review. I'm hoping to keep this video under 18 minutes, I guess. Here we have determine the volume in liters occupied by 14 grams of nitrogen at STP. So here, what are our equations? We're going to need 2 equations. We're going to need one for the chemical amount. N equals M divided by M mole. That's if you know the mass and you know the molar mass, you can calculate the chemical amount. But we're not given the molar mass. We have to calculate that too. Molar mass of nitrogen gas. Oh, here's a little detail for you. A picky detail that you might not know or that you might not remember. Nitrogen gas is a diatomic element. This means that nitrogen atoms get lonely. They don't just float around on their own, at least not in our atmosphere. When they meet other nitrogen atoms, they click together and form diatomic molecules of the element nitrogen, N2. So if you want to know the molar mass of nitrogen gas, you've got to multiply that molar mass from the periodic table by 2. A molecule of that, its molar mass is 2 times the molar mass of nitrogen from the periodic table. Well, it's not hard to get there. Periodic table gave me 14.01 grams per mole for nitrogen. So nitrogen gas, N2, is 28.01 grams per mole. Let's work with that. N equals 14 grams divided by 28.02 grams per mole equals 0.500 moles of N2, keeping all of the figures in here, and I'll zero in on this in a sec, including what I'm quantifying. Not only the units, but the units of what? The units of nitrogen gas. I keep this in my calculator, otherwise you might make a rounding error. Volume equals your figure, 0.500 moles of N2 times 22.4 liters per mole. I get 11 liters of N2. I'm going to zero in on that. And those both here. Plug. N equals 14 grams divided by 28.02 grams per mole equals 0.500 moles of N2. Use that. The volume equals your 0.5 mole figure of N2 times 22.4 liters per mole. Oh, and look at that. In the end, we only get to keep two significant figures. We only get 2 sig figs because that's all we got at the start. It didn't tell us 14.0, 14.00. It said 14. 1, 4. 2 sig figs in your question as the lowest number of sig figs. 11. 1, 1. 2 sig figs in your answer. Those are the 4 questions that I wanted to review, and I hope that helps. I'm going to put this answering key on Teams, and I'm going to look through your things there. I'm not going to mark them in a really picky way. I'm looking for you really to be marking your own work in a picky way. I'm going to give you a mark that is going to weight how you did on it, but I need you guys to be evaluating your own work as well. I hope that helps.